了，我们怎么面对沙龙讲座将在10分钟后开始。The salon for tonight, Sea Level Rise, Understanding, Expectation, and Mitigation is going to begin in 10 minutes. 成大思沙龙创立已经迈入第3年，在这里要再次感谢各位朋友们长久以来的支持。NCKU Thinkers Salon has been established for nearly 3 years. We would like to thank everyone for your ongoing supports. 这次的活动是成大思沙龙本学期的第1场演讲，同时也是一场英语沙龙。This is the first salon this semester, and it is also conducted in English. 希望下一学期陈思也能继续和各位朋友们一同成长，谢谢。We hope that in future semester, the Thinkers Salon can still accompany you on discussing international issues last known in Taiwan. Thank you. 我们将在7点邀请今晚的主持人赵峰院长开场介绍，并在7点5分开始 Dr. John Church 约翰曲奇博士的演讲。Our moderator, Dr. Zhao Feng, will give a brief introduction at 7 o'clock, and Dr. John Church will deliver his speech around 7:05. 本次沙龙没有中场休息，7点55分演讲结束以后，则是讲者对谈及交流讨论时间。Tonight we will not take any break during the salon, and after the speech ends at 5 to 8, Dr. Church will have a discussion with Dr. Zhao Feng and Dr. Yang Ruiyuan, and then we will take questions from the audiences. 整场活动预计9点10分结束。The salon will be ended at 9:10. 洗手间的位置，女侧位于观众右侧的出口，男侧则在您的左手方。The restroom for ladies is at the gate of your right side, and for gentlemen is at the left side. 在开始之前，麻烦请先将您的手机关机或调震动。Before we start, please turn off your cell phone or turn it into vibration mode. 由于现场即席翻译机数量有限，请各位多多包涵。We are not able to provide enough translation machines to everyone, so please accept our sincere apologies. 活动行进间，离场的观众只能在下一位观众出场时入内，谢谢各位的配合。During the speech or the discussion, audiences can only re-enter while their counterparts are leaving. We are sorry for the inconvenience, and we thank you for your cooperation. 今晚经由台北龙应台文化基金会及澳洲办事处的协助，成大思沙龙很荣幸地邀请到这次的主讲人 Dr. John Church 约翰曲奇博士。Today, through the efforts of Taipei Long In Tai Cultural Foundation and Australian Commerce and Industry Office, the Thinkers Salon is honored to have the speaker Dr. John Church with us. 与此同时，今天现场也来了几位重要贵宾。首先是我们陈思的大家长汤教务长。At the same time, we also invited several distinguished guests. Firstly, the president of the Thinkers Salon, also the vice president of academic affairs, Dr. Tang. Welcome.
Okay, John, Dean Zhao, Professor Yang, and ladies and gentlemen, students, good night. 3年前，龙应台教授，我们的杰出校友，答应给成大这个成大的思沙龙，我们是非常的欢欣，非常的高兴。3个月以前，龙应台教授给我一个 email， 说他要介绍，他要推荐 Professor John Church 到成功大学来。讲这个题目的时候，我们也是非常的高兴。成功大学作为我们教育部选定的2所顶尖大学之中的1所，其实成大有非常大的 mission， 也有很高的 vision。我们希望培养出来的学生呢，是全人的学生，是 leadership。这样的学生要有国际观，要有人文修养，要有跨领域的学习能力。今天晚上的这个机会来的，今天晚上这个机会是我们的学生 organize 的成大思沙龙，来了一个非常重要的一个人物。那他今天要告诉 跟我们分享的是，海水来了，我们应该怎么办？这么重要的题目，我告诉你，成功大学做什么样的准备？成大是5年500亿，已经今年第5年。现在我们就在准备未来5年的5年500亿的计划。未来5年500亿的计划是要看这个大学它的研究的声望能不能解决世界上重要的问题。成功大学推出至少会有2个 center， 一个 center 叫做 Center of Energy Research， 能源，因为成大的能源在全世界是排行10几名的研究成果。另外一个是防灾。这2个 center 呢，其实今天晚上我看到很多我们的同仁，还有我们的研究生在场啊。海水来了要怎么办？第一个，海水为什么会来？这个跟温室效应有关系，跟冰山融化有关系，水上升。这个是人类把 energy 消耗得太厉害所导致的一种结果。所以成功大学在 energy 上做研究，主要是要来 prevent， 看看能不能这个 global warming 我们可以做一些事情。第二个是防灾，海水来了，这个灾害非常的大。成大有台湾最有特色的永续环境，还有防灾的中心，所以我们都可以一起来解决这个问题。非常庆幸的，今天我们有这么好的这个 speaker 在这里，各位也非常对这个题目非常有兴趣，所以我就不多说。我想，作为成功大学的教务长，我们是非常的 privileged， to have Professor John Church， to have Professor 赵峰 ，and to have Professor 杨瑞元。Let's welcome them. Thank you very much.
今天2位的与谈人，成大海洋环境与工程技术研究中心的杨瑞元博士，以及中央大学地球科学系的赵峰院长。And two discussants for today, Dr. Yang Ruiyuan from Tainan Hydraulics Laboratory and the Marine Environment and Engineering Technology Research Center in NCKU, and Dr. Zhao Feng from National Central University. 赵峰院长同时是今晚沙龙的主持人。Dr. Zhao will serve our moderator tonight. 赵院长毕业于台湾大学物理系，在修过中研院邓大亮院士的课之后，决定攻读地球物理，并在美国加州大学圣地亚哥 Scripps 海洋学院取得博士。在2006年接受中央大学邀请返台之前，任职 NASA 20余年，担任 NASA Goddard 太空飞行中心太空测地实验室主任，现任中央大学地科系暨地球物理研究所教授兼院长。Dr. Zhao Feng is a professor and dean of the College of Earth Sciences in National Central University at present. He graduated from Department of Physics of National Taiwan University. After taking Dr. Deng's classes, he made a decision to study Earth Sciences and enter Scripps Institution of Oceanography, University of California, San Diego. After he got a PhD there, Dr. Zhao works for more than 20 years in NASA Goddard Space Flight Center. 赵峰院长曾经形容海洋学院所学念起来非常痛快，进入其中是种对智慧的挑战。今天他将如何引领大家享受挑战智慧的痛快？接下来就让我们拭目以待。欢迎赵峰院长。Dr. Zhao once described the training in Scripps Institution of Oceanography as an extremely joyful challenge to wisdom, and tonight he is definitely going to bring us another joyful challenge. Now let's welcome our moderator, Dr. Zhao.
谢谢诗怡。思沙龙办这么大一个盛大的这个演讲会啊，我们讨论一下这么重大的议题啊，很令人感动啊。刚才我们路上John Church听到说，我们这个地方可以容纳500人以上 他真的吓了一跳啊。其实我也小小的吓了一跳，吓了一小跳主持人当然不是今天的主角，不过既然你们已经知道，我是谁，我倒蛮想知道你们是谁。应该大部分都是成大的同学吧，还有老师，还有几位老师，是不是啊？都是成大的同学都在，都大部分是不是这样？谢谢。我听说台南乡亲们的这个应该是最热情，应该是成大这样。那还有应该是有蛮多从外地或者成大以外的这个社区跟甚至是不是有高中同学？因为 John Church 他自己也是蛮好奇的，他想知道说我们这个audience 的这个构成啊是怎么样。那从外校或者甚至外地来的举手，我们看看好不好？谢谢啊，欢迎，真的，我说蛮感动的，真的是这样啊，因为大家能够关心到这样一个很重大的，这是我们人类目前真的要很严肃面对的这么大一个议题从学生从年轻人开始，我们都有这样的认知，有这样的关心啊，真的是很感动。我想花2分钟先跟大家介绍一下 Dr. John Church。大家假如看到手边资料，应该有介绍他现在任职呢是在澳洲一个政府的机构CIRO。这个机构应该就相当于中央研究院那样的一个地位。他在那个机构里面，他是负责气候的这个研究组的负责人。假如你看到它里面的内容的话，应该可以看到他这么多年呢，一直都是在气候大环境变迁的这个议题上面呢，在全世界不管是联合国的国际的，甚至澳洲本地的这个大型的海洋方面的研究主持人，一直都做了很多这个很重要的贡献。最近几年也得到好几个就是国际上海洋方面的大奖。这些其实并不是最重要的也相信大家也不是最感兴趣的。最重要的是他在这个海洋海平面变化这件问题上，他孜孜不倦地做了20多年的工作。累积的成果呢，已经在这个问题上，他是就是毫无疑问的是世界级的权威专家。这个问题当然现在最近几年，因为全球变迁的这个缘故，已经变成显学可以说是跳到台面上来，太重要了。那Dr. Church 也就因为这样呢，因为他是在这方面的权威人士了。像我虽然也在这方面工作了很多年，我们都算是后进了。我认得 John Church 也是，当然是因为这个工作的关系但是很早我就对他已经可以说是相当的崇拜这是我们科学界对他的一个非常高的一个评价。那他在这方面工作，我举一个例子，就是大家可能都知道IPCC 对不对 ？Intergovernmental Panel for Climate Change。上一期的这个报告，每4年有一个这是联合国组织的一个全世界最顶尖的科学家组成的所谓小组，当然不是小组是几千位科学家每4年替这个我们地球等于说做一个总体检这样的一个意思。在第3版的时候，其中有一个主要的章节就讲到海平面上升这件事情呢，就是 Dr. Church 他是主笔所以以这样的一个例子，大家也都应该都知道，第4版在2007年拿到诺贝尔和平奖的跟高尔一起共同得到诺贝尔和平奖，可见得这个事情的本身的这个重要性跟他受到的注意。这只是一个例子。今天我想大家来呢，应该有2个目的吧。一个当然是最重要，就是来听听、来知道、来学习在这个问题上，在海平面这个问题上听听这个最新的资讯、最新的知识的这个累积。 这一点毫无疑问，你们在这1小时之内要听到的呢，保证是在这个议题上的正确版，而且是权威版可以说你们假如听完今天仔细听内容非常的丰富，听到的任何的讯息，你今天听到的就是你的知识了这个是第一手资料。我其实蛮担心的，我们平常在媒体里面接触到都是第2手、第3手，甚至有扭曲过的这个不确实或者不完整的事实，其实是蛮伤害的。今天大家听到的是完整版、正确版、权威版，是假如你听到记得的这个内容的话，甚至你可以将来说，听到不一样的声音的时候，你会可以讲回去说，你讲的不对啦，正确的应该是怎么样怎么样嘛，对不对？这个我想是今天大家来的最重要的一个目的。另外一个，我想大家应该也可以感受一下，耳濡目染一下就是这个科学的大师，真的是科学界的大师来跟大家讲一个他最清楚、最熟悉的一个题目。Dr. Church， 你们可能待会会注意到，他做人非常的谦和，做学问也是一样，非常的谦和，做这个态度非常的客观，他讲的事情不会，他知道的事情都是有证据的，他讲的事情是言无不尽的，可能你不会听到他讲一些很耸动的这些这些语句这是必然的。昨天我们在这个记者会里面，他特别跟记者讲到一句话，他说，希望其实你们不必去夸大报道任何我们讲到的议题因为真正的事实已经够令人害怕了，不用再夸大了。那我们今天就要听听这个我们这个 Dr. Church 要带给我们什么？让这个完了以后呢，我们中间有一段的时间，有2位与谈人我杨教授跟大家合起来来继续追问他各式各样的问题还有一些有关台湾的问题，也希望大家能够提出来问，至少杨教授跟我还勉强还可以知道一点，可以回答Okay, without further ado, let me give you Dr. John Church.
Thanks very much, Ben. Distinguished guests, ladies and gentlemen. Before I talk on a subject which I have become passionate about over the last recent years, let me first thank the Long Yang Tai Foundation, and particularly Madam Long and Li Yingping, for inviting me here to Taiwan. And Ben Chao has a role to play also in encouraging me to come. And also thank the Australian Commerce and Industry Office for facilitating the visit. So tonight I'm going to talk about a subject, as I said, I've become very passionate about, which I think is critically important for the future of our society. Sea level rise, understanding, expectations, and mitigation. What I'll talk about tonight, I'll start off with a bit of an introduction, some motivation as to why this might be an important issue for us. Some few points about how we actually observe sea level change, how it is changing, and why it is changing. How is it likely to change into the future, both during the 21st century and beyond, and what are the potential impacts, and how might we as a society adapt to these, and finish off with a summary. So what can we learn from history? Shown here is sea level over the last 140,000 years compared to present. If you go back to the last interglacial period, about 130,000 years ago, sea level was higher than today, perhaps 4 to 6 or even more metres higher than today. And coming into that period, the rates of sea level rise were large, perhaps as much as 1.5 meters per century. And both of these factors occurred at temperatures that we would expect to happen late this century. Over the next 100,000 years, into the depth of the last ice age, sea level fell by over 120 meters as major ice sheets formed on North America and Northern Europe and Northern Asia. And to some extent, the Antarctic ice sheet also grew. Sea level then rose rapidly, rates of 1 meter per century for many millennia, peak rates of perhaps 2, 3, or even 4 meters per century. However, after about 7,000 years ago, the major ice sheets in the Northern Hemisphere on Northern America, Europe and Asia had largely disappeared, leaving just the Greenland ice sheet as a relic from the last ice age, and the Antarctic ice sheet. Sea level largely stabilized, and over the last couple of thousand years, sea level has been relatively stable. And it's during this period of stable sea level that our coastal society has developed. This shows just one example of how our development of the coast has changed. This is a location in Australia, the Gold Coast, a very popular tourist resort. The picture on the top is in the 1950s or 1960s, and the bottom picture is a recent picture. So during this period, the coastal population in this area has grown tremendously, more than a factor of 10. And in addition, there's a huge number of tourists who pass through this area every year. So while we have moved closer to the coast, we enjoy the coast and we love the coast, it also makes us more vulnerable. So what are the potential impacts that we could think about? Could sea level rise be dangerous? What are the key impacts in the coastal zone? And we need to think not just about the mean sea level rising, but it's the interaction between that sea level rise and extreme events that will impact society. That's how most climate change will be felt, through the interactions of natural variability together with long-term change, leading to a change in the intensity and frequency of extreme events. So firstly, there's flooding, perhaps the obvious result of sea level rise, whether it's in Western countries as shown on the bottom left, or in Pacific Island nations shown on the top right. The top right picture is from Tuvalu and shows water outside the Weather Bureau in Tuvalu in a high tide situation. Not a storm surge, just a normal high tide situation. Storm surges and waves can impact on the coastal zone, damaging infrastructure, houses, jetties, wharves, ports, roads, etc. Long-term coastal erosion, whether it's chronic erosion or episodic erosion. The bottom left shows a picture in the US, and similarly the picture up here in the right is also from the US. But it's not only in the US. A picture from Africa showing erosion of the coastline eating into a coastal road. And these two pictures on the bottom right from the UK, taken about a decade apart. The bottom picture is the first picture, and the yellow line shows where the coastline in the upper picture has retreated to. And the yellow line in the top picture is where the coastline was originally. So we can see there's been houses, infrastructure, and roads lost in this area, despite efforts to protect the region. We need to think about impacts on emergency and escape routes. These plenty of pictures from New Orleans, from people who are trapped, unable to escape the flooding of New Orleans because the emergency and escape routes were blocked. Environmental refugees will be an issue that we will have to deal with. We are already dealing with. It will become more acute during the 21st century and beyond. It's not if there will be major events occurring, it will be when and where they will occur, and how we as a society will respond to those cries for help. And of course there are associated issues with this of security, food and water security, the flow-on effects to health and poverty. What are the consequences to our far and near neighbours? What are our responsibilities in helping them? So how do we observe sea level change? I'm only going to focus on the last couple of thousand years, and shown here is what is called what is an ancient Roman fish tank built about 2,000 years ago. These are the walls of the fish tank in the top left-hand corner, and down in the bottom right-hand corner is a sluice gate which allowed water to flow in and out of the fish tank to control the water level. So clearly this sluice gate had to be at water level. By examining the exact height of this fish tank, allowing for vertical land motion, then what you find is that there has been little change in sea level from about 2,000 years ago until about 1800. Some other examples, the top right shows a series of raised coral reefs in the Huon Peninsula in Papua New Guinea. And you can use these also to determine sea level in the more distant past. An example of a well off the west coast of Israel from about 8,200 years before present. An example of a Bronze Age carving in southwestern Sweden, now covered by water. Modern day sea level low is measured by coastal tide gauges. These are generally simple devices, or they were simple devices early in the 20th century, essentially a float sitting in a tube in the ocean, and as the level of the water went up and down, the float went up and down, and the level was recorded in these boxes. So the first example up here on the left is an example from Antarctica, from Venice with St. Mark's Square in the background. A modern gauge in the Pacific. This is an acoustic gauge which measures sea level by sending an acoustic pulse and bouncing it off the water surface. A modern radar gauge and modern satellite altimeters. The important part about all of these instruments is that you need to relate the sea level measured by the gauge to the actual level of the land, so that datum control is critically important in these instruments. And of course today we rely very heavily on satellite measurements for observing all sorts of parts of the climate system. So you have a satellite roughly 1,300 kilometers height. It sends down a radar pulse which bounces off the Earth's surface and back to the satellite. By measuring the time of flight very accurately, by correcting for the amount of water vapor and air pressure in the column below the satellite, you can actually determine the distance from the satellite to the surface. If independently you track the satellite through either laser ranging systems or through GPS systems, then you can know where the satellite is with respect to the centre of the Earth, and therefore know where the water surface is with respect to the centre of the Earth. So what do these measurements tell us? If we look at the longest historical sea level measurements at places like Amsterdam, Brest in France, location Sheerness in the UK, Stockholm, all of these records are showing a concave up. So they're increasing in slope up to the right. So the rate of rise has increased from the 18th to the 19th and to the 20th century, and in particular from the 19th to the 20th century. And they also show a very similar pattern. If we combine these measurements together with satellite altimeter observations, then we can estimate the global average sea level from 1850 to the present. Firstly, in the top right-hand corner here, are the observations from satellite altimeters. So these are direct observations of the global average sea level, and they show a rise over this period of somewhere in the range 3 to 3.4 millimeters per year from the launch of the satellite or the start of records in early 1993 up to the present. The blue curve is what we estimate for sea level from 1850 through the latter half of the 19th century, through the 20th century and up to the present. And firstly, you note how well the in situ measurements of sea level, that's the coastal and island measurements of sea level, agree with the satellite over this latter period. But they also show that the rate of rise has increased from the 18th century to the 19th century and during the 19th century, and over the last 15, 18 years, the rate of rise is approaching twice the average rate for the 20th century. The rate of rise, so, as revealed by satellite altimeters over this period from 1993 to 2008, is not uniform. There's a larger rate of rise in the Western Pacific, perhaps 3-4 times the global average. In the Eastern Pacific, actually, sea level fell slightly. So to the north of Australia, there was an above average sea level rise, even in Taiwan, slightly above average sea level rise during this period. But this is not a stable pattern. This is a pattern associated with climate variability, in particular the El Nino Southern Oscillation phenomena, which brings drought and flood cycles to many parts of the world, including my own country of Australia. So why is sea level changing? What is causing this rise in sea level? Firstly, warming of the oceans. Just as when you warm liquid in a thermometer, the level of the liquid rises, so if you warm the oceans, the level of the oceans rises. So we can measure the warming of the oceans. These days, one of the prime instruments are these profiling floats called Argo floats. They drift around at depths of about 1 kilometre in the ocean for the order of 10 days. Then they sink down to 2,000 metres, then rise up to the surface, measuring temperature and salinity as they go, and then transmit that information via satellite back to ground stations, and then sink down and repeat the cycle. So we now measure the upper 2 kilometres of the ocean virtually globally with these instruments. There remain some gaps in the array, but it's largely complete. We can also lower instruments such as this, what's called a CTD, conductivity temperature depth instrument, lower it from research ships, or drop expendable probes from research ships. So there are many techniques for measuring at least the upper part of the ocean. We have less comprehensive measurements of the deep ocean. The oceans absorb vast amounts of heat. If you want to understand how the climate system changes, and in particular how it responds to climate change, you need to measure the ocean heat content. The top panels, top bars here, show the amount of heat absorbed by the ocean from 1961 to 2003 in the top blue bar, and 1993 to 2003 in the second bar. The important point of this diagram is not the magnitude here, which is a huge amount of heat, 14 by 10 to the 22 joules over this time, far more than the burning of all fossil fuels. It's that the heat absorbed by the ocean actually dominates the climate system changes. So by comparison, the amount stored in glaciers and ice caps is tiny. The amount stored in Greenland from melting of the Greenland ice sheet is even smaller, from the Antarctic ice sheet. Some heat stored in warming the continents, and a small amount also in warming the atmosphere, and a little bit in melting Arctic sea ice. But the oceans dominate here. The heat content of the upper 3 meters of the ocean is equivalent to the entire atmosphere. One of the interesting things that we discovered actually by accident really, was that violent volcanic eruptions such as Mount Pinatubo, shown here, are important for changing the heat content of the ocean. So this eruption in Mount Pinatubo in the Philippines on June the 15th, 1991, these are very violent eruptions, eject aerosols into the stratosphere at heights of 20 kilometers and higher. These aerosols reflect solar radiation and lead to a cooling of the Earth, and we actually see that in cooling of surface temperatures, and we also see it in a cooling of the ocean over the 18 months or so following major volcanic eruptions. The oceans and the climate system gradually recover, but I find it remarkable that volcanic eruptions are having such a far-reaching impact in the climate system. You can actually see that in this graph. Our estimates of ocean heat content is shown here in black, and on the bottom are the three major eruptions: Mount Agung in Indonesia in 1963, El Chichon in Mexico in 1982, and Mount Pinatubo in the Philippines in 1991. And following each of these eruptions, you see this fall in ocean heat content or thermospheric sea level rise, the ocean thermal expansion, as a result of the impact of the aerosols from volcanic eruptions. So changes in ocean heat content are perhaps one of the largest contributions in the thermal expansion to sea level rise. Another very important one is the melting of glaciers worldwide. So these are glaciers in places like Patagonia, Alaska, the Himalayas, and also in Europe, as demonstrated here in this diagram. The figure on the left is a picture from 1900 showing the Rhone Glacier descending down the mountain to just behind these buildings. Significant meltwater flowing off the glaciers and down to the ocean. Essentially no trees at all in this area in 1900. 100 years later, the glacier has essentially disappeared. Trees have begun growing in the valley, they've actually begun growing up the hillside, and what was a strong stream of meltwater has now dwindled to a trickle. Worldwide, you can see many such pictures, and there are quantitative estimates for the contribution of melting glaciers to sea level, but only a small number of the many thousands of glaciers have been adequately measured. And of course the big question is, what about the two ice sheets? The relic Greenland ice sheet from the last ice age. It's losing mass from surface melting. The red coloured area in this diagram shows the melt extent in 2005. Roughly half of the snowfall on the Greenland ice sheet runs off as surface melt, and the remainder flows into the ocean as ice, carving off icebergs in those outlet glaciers. The amount of melt has increased over time, as shown from the panel in the bottom left-hand side, and there's been an increase in the area of melt from 1979 to 2007 of about 20%. Here's a picture of some of that meltwater, a lake formed on the surface of the Greenland ice sheet during the summer period. That meltwater flows off the ice sheet into the ocean, and it can flow down through these holes in the ice, called a moulin, down to the base of the ice sheet, lifting the ice off the bedrock and allowing it to slide more rapidly into the ocean. This has some impact on the rate of motion of the ice sheet, but is thought not to be the dominant factor, and we'll come back to that. You can measure the thickness of the Greenland ice sheet or the mass of the Greenland ice sheet using gravity missions. And shown here, all these blue areas around the outside of the Greenland ice sheet are areas where the Greenland ice sheet is thinning significantly. Particularly this area in the west here, which is a major outlet glacier, perhaps the largest outlet glacier for the Greenland ice sheet, significant thinning over recent times. Similarly, if you look in the Antarctic ice sheet, particularly in this West Antarctic ice sheet. Significant thinning all around the embayment here. The West Antarctic ice sheet is grounded below sea level. And this allows ocean water to penetrate under the floating ice shelves, melting them at the base, making the ice sheet more unstable and allowing the ice to slide more rapidly into the ocean. A very simple analogy you could think about is to take an ice cube and put it on a table and watch the ice cube slowly melt and the water run off the table into the ocean. Or alternatively, you could take the same ice cube, lubricate it at its base, and tilt the table. And the ice cube very rapidly slides off the side of the table or into the ocean. A much more rapid process than just surface melting. Another contribution from our moderator today, Ben Chow, who quantified the amount of water stored in terrestrial dams and reservoirs that have been built around the world. The building of these dams accelerated after the Second World War, peaking in the 1970s and then falling again in recent years. The blue dotted curve here is his estimate of the amount of water stored in these terrestrial reservoirs from 1900 to 2007, and it's about 23 millimetres. But in addition to water being stored in the land, it actually also seeps into the surrounding soil, so the amount of water stored on land is more than just the volume of the reservoirs themselves, and totals about 30 millimetres. So this has actually offset some of the sea level rise that would have otherwise occurred. But there's also the mining of groundwater from aquifers, which we use for irrigation, for watering, for cities, water supply for cities, and that much of that eventually finds its way into the ocean. If we take all of those components together and add them up from 1960 to the present, then this is what we get. The red is the sum of all the contributions over this period from 1960 up to the present. The blue with the shading is our estimate of sea level rise over the same period from the coastal measurements, the solid line, and from satellite observations, the dotted line. And we see they approximately agree. We have an approximate understanding now of, quantitative understanding of the reasons for sea level rise. And this is a significant advance even since the last IPCC report, where they could not manage to explain the observed rise over the last 50 years. So how is sea level likely to change in the future? Armed with this improved understanding of why sea level is changing and also how it is changing, we can look what might happen in the future. Shown here are the projections of sea level rise from both the third assessment report released in 2001 and the fourth, and that's shown by these green shading and the solid lines, and the fourth assessment report shown by the bar plotted at 2095. The bottom half of this bar, the purple mauve part, is principally from ocean warming and melting glaciers and those components of the ice sheets that we understand relatively well. That is, the changes in snowfall and the changes in meltwater. The top bar is an estimate of what might happen from the sliding of ice sheets. This is much more poorly understood, but it is potentially a significant contribution, and potentially it could be larger. We cannot exclude larger values since our current understanding is inadequate. If we actually compare the observations, just before I go to that, so the total rise here is the order of 80 to 90 centimetres compared to 1990s levels at the top of the band, and about 20 centimetres at the bottom of the band. So 20 centimetres to 90 centimetres, and there's two reasons for that broad range. One is how much greenhouse gases we will release into the atmosphere. So that's a decision that you and I will make during our lifetime, and particularly you will make during your lifetime. And there's also uncertainty, particularly uncertainty associated with how the ice sheets will behave. And it's important to recognise that the ice sheet uncertainty is essentially one-sided. It could lead to a substantially larger rate of rise than observed, than computed, but it's unlikely to lead to a significantly smaller rate. Now we can compare the projections with what's happening from 1990 to the present, and when we do that, we find that sea level is actually tracking along this upper limit of the projections. So that's the curve that leads to roughly 90 centimetre rise by 2100. That's not to say that sea level will continue to track along that upper curve. It could either diverge either above or below. Again, there's a regional distribution of sea level rise. Our understanding is poor about the regional distribution. The areas we're stippling on this diagram, such in the Southern Ocean here, are where most models agree. And we see that in most of the ocean there are significant differences between various models. But the common features are less than global average sea level rise in the high latitudes of the Southern Ocean, a band through the mid-latitudes in the Southern Ocean, and to some extent the Northern Hemisphere oceans as well, of above average rise and above average rise in the Arctic Ocean. What about the longer term? What could happen? Again, we can turn to history to see what has happened in the past. This shows a plot of carbon dioxide levels versus sea level. Current values of, or pre-industrial values of sea level of 0 and roughly 280 parts per million of carbon dioxide. The last ice age and previous ice ages where sea level was 120 metres or so below present day values, and carbon dioxide concentrations were somewhat smaller. But if we go back further in time, we see much higher sea levels, up to about 70 metres higher than present day values, with higher CO2 concentrations. So where are we now? We're currently at about 380, 390 parts per million, so we're moving up this curve to the left, consistent with higher sea levels. If you consider all greenhouse gases and not just carbon dioxide, then we're at about 450 parts per million and CO2 equivalent. So quite a way up the left of this curve, implying larger sea levels. This is not a mechanistic understanding, but it is a warning for us that perhaps there's something happening here that we need to be careful about. So how might it happen? Oceans have got very long timescales. Shown on the left are model results for what would happen for various greenhouse gas scenarios. Here we've allowed the greenhouse gas to rise up to 2100 and then assumed that we stabilised it at 2100 values in this green and the blue curve. The second panel shows surface temperatures, and surface temperatures largely stabilise. There's a slow gradual rise for several centuries, but a much lower rate of surface temperature rise than during the 21st century. However, for sea level in the bottom curve, you hardly notice the stabilisation of sea level following the stabilisation of greenhouse gas concentrations. This is because of the very long timescales associated with the ocean, and warming of the ocean, thermal expansion and rising sea levels will continue for many centuries. Stabilisation of emissions, of course, results in even larger rates of change. An absolutely critical issue for us to consider is the Greenland ice sheet. Currently, about half of the snowfall runs off as meltwater. For a temperature about 3 degrees Celsius above pre-industrial values, then the amount of meltwater approximately equals the snowfall, leading to a long-term and ongoing decay of the ice sheet leading to meters of sea level rise over thousands of years. However, there could be a faster response associated with the sliding of the ice sheet. But it's critical to remember that this is a critical threshold, and it's a threshold we could well pass late this century. And we've already seen the sliding of ice sheets. This shows the major glacier in West Greenland, Jakobsveld Isby Glacier, and these are very large icebergs which have slid off the Greenland as a result of warm ocean water penetrating underneath the ice shelves, eating the ice shelves away at the base, and allowing the glaciers to flow more rapidly. So what are the potential impacts and what are our adaptation options? Storm surges are a major impact. If you look at vulnerable areas like the Bay of Bengal, then there have been a whole series of major storm surges which has had major impacts. 1973, over 300,000 people killed. 1991, 140,000 people killed, and 10 million people made homeless essentially overnight. So there's a large number of storm surges which has impacted this area. Similarly, Europe has had impacts of a major storm surge. Over 2,000 lives lost in Europe in the 1953 surge. This is actually a picture from the UK where there are several hundred lives lost. What is at risk? A plot of the counts of various things, a land area, population, and GDP versus sea level. And what we notice if you look at 1 metre, just the first 1 metre above current day high tide level, about 150 million people live within that 1 metre. And there's roughly $1 trillion of GDP generated in that same 1 metre. So these are large numbers. There's potentially significant things at risk for our society. Many of our coastal megacities, cities like Mumbai, like Dhaka, are very close to current day sea level. They have very large populations, with part of those regions being very vulnerable to sea level rise. In addition, many of the delta regions around the world are sinking. The deltas are made of sediments brought down from the mountains. These naturally compact over time, and if you withdraw water from them, as we do in many areas for irrigation, then they compact more rapidly. So it's a combined impact in these areas of both sea level rise, the compaction of sediments, the sinking of land, and of course extreme events through storm surges. And of course extreme events impact us now. A picture from Galveston showing the storm surge flooding the city. Another example from Venice. This is one of the well-known pathways in Venice during flood time. They actually have to put out these tables for people to walk along what would normally be a normal pathway underneath here. The number of these flooding events has increased during the 20th century, and if we look at Australia, we can also see that both on the east coast and the west coast of Australia, at Fremantle on the west coast and Sydney on the east coast, when we look at the 20th century record, we see that flooding events of a given magnitude are occurring significantly more frequently in the latter half of the 20th century than in the first half of the 20th century. And if we take that ratio and project it forward with just a half a metre of sea level rise, quite a conservative amount of sea level rise, that we find that for many Australian locations, what is currently a rare flooding event, what's called a 1 in 100 year flooding event, would be happening several times per year by 2100. So we basically have 4 options. Firstly, if we're going to avoid the most severe impacts of climate change and sea level rise, we need to reduce our emissions. But we will need to adapt as well. We can retreat from the coastline and that's already happening. Here's an example in the UK where they're abandoning part of this coastline and taking the coastline back to this level. We cannot afford to protect all areas of our coastline. We can accommodate for sea level. We can change our building design. This is an example of a storm surge shelter in Bangladesh where people retreat to during storm surges. These constructions have saved thousands, tens of thousands of lives over recent years. And in some areas we will actually choose to protect our coastline. Shows the Thames barrage in the bottom left. This is a barrier across the Thames River which protects the City of London, protects about £100 billion of assets which are behind the Thames barrage. So we have here an example of flooding on the seaward side of the barrage. Just a couple of years ago, a storm surge went within centimetres of overtopping the Thames barrage, so UK is actively planning to extend the barrage. And on the right, a barrage in Rotterdam. So in summary, our society has developed during a period of relatively stable sea levels. That has now changed. The rate of rise is an order of magnitude larger now than during the previous 1,000 years. We are currently tracking along the upper edge of the projections, and there is significant uncertainty with what will happen to ice sheets and how much more they might contribute to sea level rise. So the science shows that ongoing sea level rise is virtually inevitable. It's happening now. It will have a bigger impact during the 21st century, and it will be a longer term issue. Sea level will not stop rising in 2100, but continue rising for many hundreds of years. We are going to need to adapt. We need to think about inundation, of coastal erosion, impact on both the built environment and the natural environment. Coastal flooding events will become more frequent and more severe. The least developed nations, of course, and the poor are most at risk, and will require local and regional planning to adapt to the situations. But we also need to mitigate to avoid the most extreme scenarios. Without significant, urgent and sustained action, we could pass a threshold that leads to an ongoing melting of the Greenland ice sheet, committing to the world to sea level rise of metres over coming centuries. So I really believe if we are to avoid this situation, then urgent action is required. We need short-term emission goals. But I don't think we should face this future pessimistically. There's much we can do. We can reduce our demand for energy. We can use energy more efficiently. There are more efficient devices. You only have to walk out into the car park and notice that some cars use probably 3 times the amount of fuel as others. We can use renewable energies. We can store carbon from coal-fired power stations. What's really required here is the will from us and our governments to do it. This is such a critically important issue. I believe that it's our actions, our pressure in government, which will finally result in action. So we can do it. I think there is a message of hope here that we can mitigate to avoid these worst-case scenarios. Environmental refugees will be an issue for us to deal with. There is no legal convention that covers the situation of environmental refugees, but it is a humanitarian issue that we will have to deal with during the 21st century and beyond. There are a number of uncertainties, and to minimise the costs both of mitigation and of adaptation, we need to reduce those uncertainties. Observing, understanding and modelling the oceans, and particularly the ice sheets, are critical. We need to implement early warning systems so that people can be evacuated when major storm surges are coming. And we also need to know when there are major events from ice sheets. Are we actually seeing a more rapid response of the ice sheets? And to implement these, it's essential and urgent that science, government, business and community partnerships are built and strengthen during the 21st century. Much of what I've spoken about tonight is in a forthcoming book to be published by Blackwell on understanding sea level rise and variability. And I thank you for listening and look forward to your questions.
Thank you very much, John. 我想大家听到这么多这个最新、最这个正确的讯息，应该需要消化一下。我们在接下来呢，就请John and 杨瑞元老师，大家应该很多成大同学都认得杨老师，他是海洋环境中心的教授。那我们在接下去，我们时间应该就是说，我们还有在他们把我们赶出去以前，有1小时的时间。我们在这1小时之内呢，我们希望能够由我们3位先等于说把刚才的一些议题呢，有一些把它仔细的像因为到底我们台湾也是这个整个议题里面重要的一个受到影响的一个群体我们特别有什么特别的这个要从这个国外学到的一些经验以及国际上的一些做法我们可以多谈一谈。然后接下去我想请就是开放大家一起我们把这个大家最关心的问题用问题提出来的方式Q&A 那我们就请2位已经就座，那我们就从这里开始。我想大家在等于说把刚才的这么很集中的一段时间里面吸收到了这么多知识，这么多讯息，正在沉淀消化的当中呢。我刚才也听到蛮多，我自己也是对我来讲也是冲击非常大的一些新的讯息。我想把有一些问题也想借这个机会呢，问到Dr. Church， 也希望能够引起大家也注意到这些问题的存在跟它背后的这些思考。John, we're going to ask questions, of course, in English to you, but we're going to explain and pick out the main points in order for the audience to understand it more and deeper. 我想，刚才我们在介绍的时候呢，我们都提到，Dr. Church 他在过去参加这国际上这是联合国组织的 IPCC 的这个 report 里面呢，参加一个很重要的角色。所谓参加实际上大家假如注意到 IPCC 的这个 report， 在网上你只要 Google 一下IPCC 就全部都会出来那个印出来都是好几大本这样子。那里面的章节很多。Sea level rise, sea level variation 只是其中的一个章节，当然是一个非常重要的章节。在这个章节里面呢，整合了，当时由Dr. Church 主导，整合了这个所有当时全人类的在海洋界的科学家所有的智慧的结晶，是这样的一个呈现。那这个背后当然应该是有很多可以说故事，也可以说很多过程。我想请教一下这个Dr. Church， 他可以分享一些我们这个后面的事情，可以跟大家作为一个借鉴，也可以让大家知道在国际上这些事情是怎么样被讨论怎么样得到一个所谓的结论，以及后续发生的一些大家我想在媒体上也都看到过各式各样的这个可以说是批评的声音，当然都是少数。我想绝大部分的民众，绝大部分的 科学界应该都是很注意到这样的问题，也都认识到，但是总是会有不一样的 voice 出来啊，不一样的声音提出来听到。我想请 Dr. Church 也帮我们在这方面呢，做一些可以说评论吧。John, I want to ask you about what's happening behind IPCC, because all we see are on the web, in the newspaper, the final presentation of the IPCC report. But you being involved in the process of making it, in your experience, I'd like to ask you to share with us the process, the intellectual process, the scientific significance, as well as afterwards. Of course, you mentioned in the lunchtime talk that afterwards, of course, you, including the scientific community, began to hear different voices from all angles. Can you share with us those experiences, or let's call it stories?
Thanks very much, Ben. Yes, being an IPCC author is quite an experience for a scientist. It's a very demanding process. What you do is you select a group of authors from around the world, about 10 people who are very prominent in their area, and you assign them a task of writing a summary of what we know about a particular area. So the process that we used in the third assessment report was we met, we decided on an outline, and we wrote a draft, and each of the authors wrote particular components of the draft, and then it was pulled together into a complete chapter. We then sent it to our colleagues for review. These were our friends, our colleagues who we thought knew as much about the science, and they gave us a lot of useful feedback. We then met again, revised the chapter, and it was then made freely available to the world for all scientists, for the public, for interested parties to comment on. And we received, I don't know, maybe 2,000 comments. The pages of comments that we had were substantially thicker than our report itself. We had to respond to every single one of those comments. We didn't have to accept them, but we at least had to recognize them and respond to them. Now, a lot of the comments were the same, in fact. And many of them resulted in significant improvements in the chapter. We then rewrote the chapter, submitted our written comments, and the written comments and our responses are stored on the website so they can be accessible, and then went to a third round of review, which is for governments to look at the magazine. And typically what governments do is collect their national scientists together and give them the report and say, what do you think of this report? And then we get a series of responses by governments, again a similar length, perhaps a little bit less in this round, and again we revise the document. Then a summary from that document is written, and that's taken together with each of the individual chapters to an intergovernmental meeting. At that intergovernmental meeting, the summary, which is, I don't know, about 18 pages long, is approved by all governments around the world on essentially a sentence-by-sentence basis. So you work through these 18 pages with the governments making comments. The scientists are there and present to ensure that scientific accuracy is not lost in the rewriting of the document. And this usually results in significant improvement in the way the information is communicated in particular, because the governments have a different viewpoint and different understanding of that of the scientists. The science message is not changed. It can be severely questioned, but in general, the science message is not changed. It's a very laborious process, this line by line approval of 18 pages of document. I know on the first day of the meeting, I was exasperated by about lunchtime when we had set up a working group to investigate the first sentence, approved the second sentence, set up a different working group to approve the third sentence, and then somebody called for a break because they hadn't considered the next sentence. So this went on for a week, finishing after midnight, usually most days. But it's quite an experience, and it's a good process, I think. It's very rigorous, it's very demanding. Ben referred to what happened after the most recent IPCC report. So I was not an author on the most recent IPCC report, but a number of us actually wrote a paper which showed that sea level was tracking along the upper edge of the projections. And I guess we sort of knew that before, but it hadn't actually been written about and rigorously done and published. And so that's actually opened up a lot of questions from people saying, well, maybe these models are underestimating the amount of sea level rise. And they started to develop simple statistical models which relate surface temperature to sea level. So they actually use our sea level curve, global temperature curves, and do a correlation between these and attempt to project future sea level rise. All of the papers that have been published using these approaches have resulted in higher rates of sea level rise than in the IPCC report. So the question is, how robust are these very simple techniques? They're not based on physical understanding, on the mechanistic understanding in the same way that the IPCC projections are. My personal view is that that we should first trust the physical-based models for future projections, but that these simple projections are perhaps a warning to us that perhaps there are other things occurring and that we need to be careful here. We need to re-examine the models, we need to be more rigorous in trying to improve our understanding and understanding the differences between the observations and the models. So I think we should stick at this stage to the IPCC projections, but we should note the other projections and be aware that perhaps a larger sea level rise could occur. And I think there'll be significant progress made on this in the next report.
Thank you, John. 我想大家听到这样的这个等于说是很第一手的这个亲身经历的这个过程呢，应该可以感受到这个科学家在背后工作，真的不是像可能拍不出什么好莱坞的电影来啊，然后拍出来恐怕很 boring 啊，真的就是在后面孜孜不倦的工作，所以像 IPCC 这样的一个report 出来，真的完全就是一个全世界在各领域里面顶尖专家的集体的智慧啊，这个 collective wisdom 的一个总结。刚才大家听到这个背后的一些真的很辛苦的工作，都是为了唤醒啊，等于说我们全人类对这些知识的这个了解跟认知。另外一点，Dr. Church 我想大家也听到，他讲到这一点，就是说有一些事后后来发生的这些怀疑，说这个 IPCC report 在海平面问题上太保守了，因为我们现在看到的情况 真的比 IPCC report 里面讲的好像更严重啊。他刚才也提到这一点，这也显示到这个做科学态度一种客观的态度。他特别强调说，确实没错，我们现在真正发生的有很多的测量这个数据显示呢，我们现在真正发生的是当初预料的这个上下限之内差不多是沿的这个上限啊，这个很不幸的啊，是沿着这个上限的这个在实际上在进行啊，这个他蛮怀疑蛮担心的是真正可能还有我们科学家都没有当初甚至到现在都还没有预料到，都还没有警觉到一些其他的事件正在发生啊，所以有可能有这样的事，有这样的这个倾向来发生啊。当然，这个以科学的客观角度来看这件事情，当然就是这个新的任务、新的挑战，要搞清楚为什么我们的当初的这个预测呢，这个 range 呢虽然很广，但是还是偏保守。这个另一方面也可以看出来，就是说，这个大自然真的没有在留情啊，真的是他做他的这个事情的时候，当然他不会去参考 IPCC 的讲的话，这个真正的事情发生，真的比我们预期的还要严重，这个情况比就是更令人担心啊！这我想今天大家可能应该可以感受到，其实我这2天跟 Dr. Church 几个场合都听到他讲这个是整个故事的时候呢，我自己是越听越害怕，不是像看那个好莱坞那恐怖片这样，你看第2次大概就不怕了，对不对？你看第3次早就知道会怎么样，根本就不会再怕了。这个真的这个事情在发生的时候，这个海平面问题，我是越听越感到害怕，这个害怕当然是一种担心，我想这个今天大家也在这里也应该都能够感受到，我想杨老师应该有不一样的 perspective， 从这件事情上请教Dr. Church。
Professor John Church. Firstly, thanks for giving so impressive and beautiful speech to let us know the serious problem of sea level rise. So my first question is that what caused the sea level rise, and now what can be done to improve the current situation? The current situation of sea level rise.
So sea level is rising principally as a result of our emissions of greenhouse gases, warming the planet. That heat is going principally into the ocean. The oceans are expanding. Glaciers are melting. They're the 2 major components, with smaller contributions from the ice sheets, but potentially larger contributions in the future. So what can be done? We can reduce our emissions, and I personally think we should be reducing our emissions very significantly. But we will also need to adapt, and that adaptation will be mainly done locally, and that will require society at the regional level to make those decisions of how we adapt, whether we abandon sections of a coastline and protect others.
My second question is that because my major is in coastal engineering, and in Taiwan, especially in South Taiwan, we have a low-lying coastal area, and we also have the subsidence problems. So for the problems of sea level rise, I think we should have some new idea of the coastal management. From your experience, do you have any suggestion for Taiwan to have the new idea of the coastal or shore protection system?
I think you actually can answer this question better than I can. But it's certainly a controversial issue. I know in my own nation there is growing litigation, court cases, between people who want to develop land, governments or local councils saying, but if you develop it, there's a high risk of it being flooded. Other people wanting to encourage development. If they stop development, they risk being sued for loss of value of coastal property. If they allow coastal development, they risk being sued from the flooding that might ensue. So coastal councils are really caught in a very difficult situation. There's growing heat between the various camps, and it's unclear what will be the outcome in some of these circumstances. But I think it does call for a rational debate. It calls for good planning, thinking ahead. Much of our planning up to date has assumed a level sea level. We've not been used to a changing sea level in our planning of cities. We have to change that thinking. We have to start accommodating. We can have different facilities near the coast, public parklands where it doesn't matter if it's flooded once a year, but you probably don't want to put a hospital there where it could get flooded regularly. So we need to think about these things into the future and think in the longer term. But I think you probably have a lot of the practical solutions as to how we should proceed.
Actually brings up another thoughts. If you think about it, Taiwan is an island. Australia is also an island, just different size island. So they share another commonality, which is people living on Taiwan and on Australia. People all live around very low level, just above sea level, around the coast. So we actually sharing similar situation and facing similar problems. As far as I know, Professor Yang can contribute more. Is the fact that in Taiwan, the awareness of the problem has been pretty high, but as far as taking actual actions, I think we're kind of very slow and probably sluggish is a more proper term. How about this refers to the governmental level, the local governmental level, and the community level. What about the situation in Australia? Maybe we can learn something or sharing information with you, depending on what other countries like Australia is doing.
Australia has been in the lead in some areas in climate change. As for almost 20 years now, I think we have essentially had a government department associated with climate change. It's now called the Department of Climate Change and Water, I think. And they have been active in supporting projections of and understanding of climate change on the scientific side, communicating that information to the public, and in the coastal area, the most recent thing they've done is released what's a coastal vulnerability study. They chose a particular sea level value and looked right around the Australian coastline and said, well, what is at risk here? What is the infrastructure at risk? What are the natural assets at risk? So this has served to galvanize action. The awareness of the issue has grown considerably. About 2 weeks ago, I was at a meeting of coastal councils around the Australian coastline. And remember, all of these coastal councils are experiencing what we call the sea change phenomena. Many people are leaving the cities and moving closer and closer to the coastline. The age distribution is changing very significantly. There are an increasing number of older people living at the coast. This, together with the changing climate, rising sea level, is a major challenge for coastal councils around Australia. They now have a regular meeting once a year. As I said, I was at the last meeting just a couple of weeks ago, talking to them about the issues of sea level rise. Many of them are being proactive in their planning. Some of them actually have an active plan now of planned retreat from the coastline and abandoning of some properties. But there are others, of course, who are resisting that, who basically want the development dollars. And those councils are generally split, actually, between people who say, well, that's a short-term solution, but it's not a good solution in the longer term. But certainly the debate is continuing. The debate is starting to enter the courts through litigation, and some of those issues will be solved by litigation. But I think planning is a much better approach and forward-looking rather than wasting money doing battles in court.
In Taiwan, because we don't have much space for retreat, so now the coastal structure in Taiwan, we want to combine the hard structure and the softer structure to have like the west defense, not only the coastline defense. We want to combine like seawall and artificial beach. So now the coastal management in Taiwan, we will focus on the integration of the hard structure and the soft structure.
And of course, this is what they're doing in the Netherlands. Much of the Netherlands, or a significant portion of the Netherlands, is below sea level and is protected by dikes. But the Netherlands government last year put together a science group to say, and asked the science group to tell them what is the upper limit of the potential sea level rise. Because they need to plan for the worst case scenario, because their worst case scenario means flooding of large areas of the country and huge loss of huge damage to infrastructure, to the natural environment, and large loss of life. So they're actually asking, what is the largest realistic number so that we can build our dikes to cope for sea level rise during the 21st century and during the 22nd century. They're actually asking us to go 200 years into the future, not just 100 years into the future. And yes, they're having the same combination of soft and hard infrastructure to protect their nation. And so in countries where land is valuable, we will choose to protect it and do those things.
刚才Dr. Church 提到一点，以澳洲的经验，也许大家应该也注意到有一点，也许是因为这个政治这个结构的不同，以澳洲的做法是当地的 community 当地的社区来作为启动点、起始点，做 planning 就是做计划，而不是说等着别人来救济我。他们是主动的，这个被影响到、即将被影响到的 社区就自己先开始做新的计划，当然事后一层一层要有州政府以及中央政府来作为整体的规划，这个我想台湾因为刚才杨老师也讲到，就是条件不太一样台湾真的是没有地方可以退了，已经满到无处可退了，所以这样的这种模式，不见得以及不一样的政治的这种结构体系，不一定能够做到。但是我想这个在概念上应该是这样，我们真的是应该要自发的想到说这个问题是自己的问题，是我们全人类每一个人都要面对的问题，不是要等到别人来救我。我们现在真的要救的就是自己要开始救自己。当然是要一个集体的行动、集体的智慧来做这样的事情。我想时间的关系，我们假如说杨老师没有特别，还有我想大家应该每个人心里面都有一些疑问，都有很想表达、很想问的问题，一定的我想我们开放给大家，是不是有麦克风可以传递一下的？
好。那我们现在开始是交流讨论时间。那想要发问的朋友们，请您举手，然后经由主持人点名之后，我们的工作人员会递交麦克风。Now it's the time for questions and answers. If you have any ideas or questions to share with everyone, please raise your hand and our staff will pass you the microphone.
你要用中文、英文都随便，都欢迎。而且可不可以把这个场的后面灯开一下？我们至少我们可以看得到。谢谢。
对不起，我想要请问那个，杨主任跟那个赵博士那我们知道现在台湾那个在嘉义布袋跟那个屏东，还有那个屏东的那个问丰村跟嘉东这些地方他们的地层下陷很严重。那我曾经听人家说过，他们是因为超抽地下水。但是我曾经有听到一个老师跟我讲说，地下水它是互相流通的。那如果说他们是抽地下水的话，为什么只有他们那个地方下陷，他们的周围一些地方是没有下陷的？这是我一个问题，谢谢。
我想那个台湾，因为我不是地层下陷的专家不过我们成大水工试验所有一个地层下陷防治服务团的那个部分的，针对这个地层下陷有一些相当的研究。那基本上造成地层下陷的部分很大的原因还是来自于超抽地下水，它的补助的速度是没那么快的。我就说这个部分就会造成相当大的这个地层下陷的这个潜在的一个趋势那目前来讲，内陆养殖的部分当然不只会造成，他们大部分都是超抽地下水来做一些这个内陆的养殖。那这个部分除了说会造成这个地层下陷的问题以外，此外呢，对于这个沿岸的部分也会产生所谓的土壤盐化的问题。那这个部分目前来讲，我们成大的研究里面也跟中山大学的研究里面，希望把国内在这些所谓陆上的养殖能够 extend 到比较海洋上面去做养殖，也就是海洋的一个海上相往的部分，希望能够提高这个养殖的这个品质。那另外也能够减少这个海水这个包括地层下陷，还有海水盐化陆地这样的一些问题。那就针对你的问题，我做这样的回答，谢谢。
我想可以稍微也补充一点，刚才同学问到的问题其实很好。那症结刚刚杨老师提到是时间快慢时间尺度的问题。假如你说地下水其实都是互相连通的，经过盐层，这句话是对的。就假如你每一年只收取很少量的水，那个补足是可以发生，这个地层不会下陷。现在的问题是超支的把水很快的把它拿掉，还没有办法补足的情况之下，地层这个盐层土层只好下陷，这一定会发生的。另外有一点我特别要跟大家也提醒的，就是 可能当然在不同的媒体或者文件里面看到一些数字是讲台湾啊，台湾的这个海平面对这个上升的情况特别严重，你看到那些数字都是非常惊人的。然后你把那些数字跟今天 Dr. Church 提出来的全球的数字比一比，你会发现说为什么台湾，我看到台湾数字是这么严重，好像全球并不是这么严重的这种数字的呈现。这个我想应该是有2个主要原因，一个就是大家有没有注意到 Dr. Church 有一张图是用卫星测高 altimeter 做出来，全世界海洋里面过去10几年什么地方在增长，就是海平面在上升，甚至有的地方在下降。这个不是讲说长期的，而是说只过去10几年有这个卫星资料这段时间里面看到的现象。很明显的看到，就是在西太平洋，也就是在从印尼、菲律宾一直到台湾这一个大地区红一大片嘛，意思就是说这一段时间10几年之内，在这个地区呢，海平面上升真的是比世界上其他地方都要严重。这个刚才 Dr. Church 有提到，就是主要是圣婴现象造成的，这个不是一个永久性。圣婴现象就是所谓 El Niño Southern Oscillation 那这个是真的，我们附近的环境就在发生的事情。仔细去看那些数字呢，真的是我们这边海平面上升的那个速率，真的是比全球平均高，差不多是2倍到3倍这样子。这是一个原因，还有一个原因实际上是，我们看这个海平面问题的时候，实际上我们注意的是相对的海平面，所谓相对的，就是海平面它不管怎么动，我们注意的是它相对于我们住的陆地来讲的上升还是下降。假如全球海平面都在上升，我们的附近海平面都在上升，那台湾也在造山运动也在上升，假如上升都一样快，其实好像没有什么影响。对的，那个影响不会直接冲击到台湾的这个情况，所以我们看的是一个相对的这个海平面变化。那实际上台湾发生的事情呢，除了附近的海平面在很快速的这个很异常的这个上升之外，台湾其实有很多地方，尤其沿海是在下降，陆地就在沉降。其中有一个这个很严重的这个原因就是潮收地下水。那个当然也只是比较小地区的，整体来讲，台湾整体你可以说，台湾其实不是在造山运动嘛，应该是越来越提高啊。这句话没有错，这是长期来讲，这是几百万年的时间尺度来讲是对的。但是以几十年的时间尺度，以我们最近多少年来10几年来的真正的实际测量结果，发现并不见得是那样，而是说台湾全沿着海边的这些陆地，其实很多地方不光是因为潮收地下水，它自然情况也是正在沉降之中。刚才 Dr. Church 也提到一点，就是三角洲河流的三角洲出海的地方，你不去每一年有足够的这个沙量去补充的话，它也是在沉降。我们在路上的所有的河都用了这个水坝把那个泥沙拦截了以后，其实河口的三角洲也都是人聚集的地方，也是在沉降。所以台湾这个问题是双重的，附近的海平面是异常的增加，而是上升的厉害，沿海的陆地又在沉降，所以大家可以看到那个数字蛮可怕的，是这个原因。实际上这个数字还不完全是可以100%相信，因为那些测量都有很大的误差，因为我们做这方面的测量也只有做最近大概5年多吧，尤其是在1999年921大地震以后才建制了很多这种测量的机制，所以第一个测量并不是很准，第二个海面台湾这边上升特别厉害。台湾沿海在沉降，这几个数字摆到一起以后，大家看到一些很惊人的数字是这样来的。 对，请那位坏人先生跟我们讲。他穿了一件 T 恤，上面写坏人。
Hello, Dr. Church. Hello, Dr. Zhao. Hello, Dr. Yang. And good evening, everyone. And my name is Bill, and I'm a student of medical MCKU, and I have a question want to ask Dr. Church. And my question is, what's your opinion about the scandal of Climate-Gate and the consequences of Copenhagen in last December? That's all my question.
The emails that were released essentially cast little doubt on the scientific position. The scientific position remains essentially as it was prior to the release of the emails. Almost all of the data that is available, that was used by these people, is freely available via various sources, either directly from the people in the UK or from the original sources of the data. There are small percentages of the data which those people actually don't have the legal right to release. They are only given it under particular conditions for scientific work, and they do not have the right to release it. That's a very small amount of the data, and generally that data is available from the original sources. So there's essentially, in my mind, no major issues associated with Climate-Gate. There were a series of allegations made about mistakes in the IPCC fourth assessment report. There was one significant mistake, and that was the comment about how quickly the melting of the Himalayan glaciers would occur. That has had no impact on the projections of sea level. The people who did the projections of sea level did not make that assumption, did not make that mistake. All of the other allegations of mistakes in the fourth assessment report are essentially incorrect, are essentially fabrications.
我想这个问题很关键，而且很等于说是把这个后面的这个事情挑起来，只是大家都需要注意的。我想可能跟同学很快解释一下什么叫做 climate gate 啊，气候门为什么叫做 gate 啊？大家可能记得讲或者读到过美国在20-30年前那个选举的尼克森总统选举的丑闻叫 Watergate 啊，是那个是他的那个总部的那个房子那栋建筑物的名字了。自从那个以后，所有的疑似这个丑闻的事件都叫什么什么 gate， 是这样来的。所以把这事情形容成climate gate， 其实是不对的，因为这个有点影射，就是说你已经是认定说你这个是在掩饰什么事情，要做一些这个错误的这个误导的事情，其实不是。刚刚 Dr. Church 特别提到，所有的正确的资料都是公开的，用不着去传闻，用不着去第二手、第三手去听闻，你直接去 IPCC 直接去看，所有的 data 都在那边。假如那边没有出现的 data， 绝大可能就是这个 data 不正确，所以没有出现在那里。我们这个世界上大家都知道，不正确的 data 的数据实在是到处都是，充斥了这个所有的地方有故意的错误的这个资讯跟数据，有误解的这个错误的资讯 跟数据，也有引用部分引用，而不引用绝大部分的，就是等于说是一种这种针对性或者选择性的利用资讯跟数据，这其实都是不对的，而且都是非常危险的。我希望我们大家能够，要对这件事情要有追根究底的话，不是去听第二、第三手的那些传闻，而是去真的去看看到底这个资料里面呈现的第一手讲的是什么，搞清楚。这一点也是 Dr. Cheng-Shing 在这边跟大家强调的。好，这边老师。
Dr. Church, I'm from National Pingtung University of Science and Technology, which is about 2 hours drive from this location. I've enjoyed your presentation very much, but there's a question or two I would like to ask you to elaborate a little bit on. In this handout information, we have understanding reading. It's entitled Understanding 20th Century Sea Level Rise and Projection for the Future. That was published or presented by you back in 2001 in November, academic symposium. That was about, 10 years ago? In this paper, you mentioned a term. It's called terrestrial storage. Terrestrial storage. And there's a lot of uncertainty about this term. What is the reason to have this term considered back in 2001? And the uncertainty has been resolved, or we understand a little bit more? This is the first question. The second question is also to you is, you mentioned there's another way that we can monitor the sea level changes, which is by change in gravity fields. I would like to know a little bit more about the latest development in this measurement technology, if I may. Thank you.
Okay, firstly, terrestrial storage. So terrestrial storage, there's a number of terms in there. The two largest terms are the building of dams and reservoirs, and the uncertainty associated with that has been significantly reduced. Ben Chow here has actually done that work and published it in Science, I think, about 2 years ago, and that's significantly reduced one of the terms, or one of the two major terms. The second term is the amount of water mined from aquifers. I might say the largest uncertainties actually were associated with the dam storage terms, so that has been significantly reduced. The mining of groundwater from aquifers and its subsequent runoff into the ocean, people are still working on that. I believe the estimates that we made in 2001 were probably, the uncertainties were probably unrealistically large. It's probably a smaller term, but that's probably yet to be convincingly proved. So there's been progress made, but not fully resolved. Measuring of gravity. So this is two satellites operating in tandem in low Earth orbit. I'm not sure what height they are, Ben. 500 kilometers above the ocean, above the Earth's surface. The two satellites are tracked very accurately, and they also measure the distance between the two satellites very accurately. And so when they go over a gravity anomaly, one satellite is accelerated, and so the distance between the satellites change, and then when the second satellite goes over, it's also accelerated, and so the distance changes again. If you repeatedly fly these missions of the same area, you can see how that gravity anomaly is changing with time. This is a remarkable series of satellites. Ben probably knows more about it than I do. The satellites have been operating for about 6 years now, 7 years. They've got a few more years lifetime. The next mission was not to be launched, I think, under 2018, but it's been recognised now that this is a very important mission, providing very new and useful information, and it's likely that it will be moved up the priority list, but I'm not quite sure where the current status is, and Ben can probably tell us.
假如对这个卫星测量重力变化，也就是看我们世界上物质流动的重新分布啊，这个对时间空间的关系这样的一个测量，这个刚讲到这个卫星计划，你只要 Google 一下的话，叫做 GRACE，G-R-A-C-E 啊，当然是一个 acronym， 应该都可以看到足够的讯息在里面。确实，他刚刚讲到这是非常非常重大的一个突破，在测量地球的全球变迁的资料，资讯上面。好，那边，那前面这位，好吧。
Good evening, everybody. I'm Claude. I have a question to Young Church. Do you think the policy of Obama in green eco solution can solve this problem? 说，你认为奥巴马的绿色经济政策可以解决这个海平面上升的问题吗？
Well, we certainly need to move towards renewable energies, energies that have less carbon emissions, so green energies. In that sense, yes, I do think it's a positive move, and I think we will, as a world, have to move in that direction. So I am hoping that he and other leaders around the world are successful in reducing our emissions.
Good evening, Dr. Church. I'm a student of biology at Kaohsiung Medical University, and my name is Grace. And I'd like to ask a question concerning, because recently I saw a Discovery Channel documentary about overfishing. And what they basically said was that I think in 2006 there was a meeting in Malta about overfishing of tuna. And scientists had set a quota of 15,000 tons that could be fished to maintain the population. But politicians negotiated a quota of 30,000 tons. And it makes me realize that there is a gap between what scientists realistically recommend and what politicians can negotiate. And so I want to know, for one thing, how can you bridge this gap? How can you bridge this gap between the scientific community and the political negotiation process? Because it's totally like different way of approaching things. And another thing is that I noticed that even though we in Taiwan, we are aware of a lot of scientific data and we're aware of the crises in our communities and in our environment, we seem like the scientists seem not very capable of bridging this gap with the government, informing policy very, very effectively. And I want to know where and like how that can be done. Thank you.
I don't think I have a good answer to that. To a large extent, the scientific community has not managed to bridge this gap. I think the way that the gap will be bridged, though, in important issues like climate change is through the public. So I think venues like this, where the public is informed, are critically important. It is also important, I believe, for scientists to be out there in the community, communicating the science as best we understand it, and also communicating the uncertainty, the things that we don't understand, as well as the things that we do understand. But ultimately, in a democracy, on such an important issue, policy is made by the public. So I think it's important that the public, in your country in Taiwan, in my country in Australia, that they voice their opinion. There are many vested interests here which have a lot of pressure, bring a lot of pressure to bear on governments. And these vested interests are not always open. We need to bring those things out into the open.
Dr. Yang, Dr. Zhao, and Dr. Church, good evening. My name is Su Tong. I'm from the Mechanical Engineering Department. And first, I will thank you for your wonderful presentation. And I got two questions for you. First of all, you mentioned a lot of adaptation, like moving the house back or something, the short-term strategy. So I wonder if there's some like long-term strategy from the scientific perspective. Like we all know that we must reduce our emission, but how exactly? How could we? Maybe you could give us some of the example. And the second question is that there's another controversial issue about the carbon trade. So I want to hear some of the opinion from you. Thank you.
Okay, the first question. There are many options, I think, for us to respond to climate change. Firstly, reducing our usage of energy, our demand for energy, and there's many ways we can do that in our own lifestyle, the way we use and the way we waste energy at the moment. For many of us and for many industries, they can reduce their energy use and save money at the same time. So this is not a matter of trading off our lifestyle or our comfort for saving energy. We can do both of those. There's significant economic savings that can be made by our reduction in energy. There are more efficient technologies we can use. I think the example I gave during the talk was you just have to walk out into the car park, at least in my country, and I can see cars that are 3 times as efficient as other cars. Yet they're doing the same thing, doing the shopping, running the kids to school. We don't need those big cars to do those simple tasks. There are renewable technologies becoming available. Wind, solar power, geothermal power in my nation is likely to be a major issue or a major source of energy into the future. We will need to develop issues like particularly carbon capture and storage because whether we like it or not, we are very dependent on coal and oil burning power stations. We can't turn them off overnight. While we need to move as rapidly as we possibly can to renewable energies, we also have to realise that we are dependent on these and we have to develop technologies to capture that carbon dioxide and storage. My colleagues in this area tell me we have the capability to do that. All we need to do is scale it up and apply it. And that requires commitment. But the most important issue in all of this, I think, is commitment from the public and therefore from the politicians to change. I think it's absolutely critical that we put a price on carbon. Without a price on carbon, the incentive to save, to reduce our energy usage will not be there. How you put that price on carbon, there's enough politicians arguing about that without me joining them.
三位老师你们好，我叫王丽芬，我是一个学生，然后我不是读任何关于海洋或者是环境工程的。那我很感谢有今天的这个机会，这个 lecture 哈，让我们可以有一点点的意识。但是我觉得这个 lecture 有一点比较不够的，就是它跟那个正负2度 C 一样，它没有告诉我们就是身在台湾的每一个人，而不是政府，是每一个人应该要做些什么。那我觉得说，像Dr. Church 他很慷慨跟我们分享他的专业知识，还有他在澳洲看到的一些东西。可是，那我们台湾自己呢？我们应该做些什么？还有我要反驳刚刚那个 Dr. Church 的一句话，就是 policies are made by the public， 但是在台湾不是这样子。如果是的话，为什么花莲的七星潭要去 BOT 我们不知道，台东的都兰比要 BOT 我们不知道，然后中部科学园区3起4起工程有违反环境正义，可是我们也不知道。那环保署做了一些违法的事，我们也不知道。那我在这里，我可能有点偏激，可是我觉得说，一旦你越接触这些东西，你就会越知道说，环境的议题在台湾有多不被重视，以及主流媒体有多不在意这些东西。好，那我没有要哭，因为我是有点紧张，所以发抖。我觉得站起来讲话耽误大家时间，就要给大家一些比较 constructive 的东西。我觉得身为台湾人，我们可以做的事情，第一点就是我们可以看下个礼拜一公视我们的岛这个节目。第二点，如果大家有笔的话，请你们写下来2个记者的名字，一个叫胡慕情，慕是羡慕的慕，情是感情的情。另外一个叫朱淑娟，这2个跑环境线的记者是我一直很敬佩的对象。然后第3点就是，如果大家有一点钱的话，我没有在替天下杂志做广告，但是我觉得他们这一期出的杂志比较深入的去分析了一些台湾水资源管理的问题。那如果大家有一点点闲钱的话，可以去看。那没有的话，我相信成大图书馆应该也有。好，谢谢。
好，谢谢。谢谢大家都听到这3点啊。那刚刚这边同学，那边好不好？我们跳来跳去。
I have some suggestion. I think there's no other way that the human society avoid the climate and resource crisis except giving much more ethical treatment to the other sentient beings and the environment. It's not surprising that this civilization would ruin when we think ourselves civilized and peace, but still butchering countless animals that could feel pain and fright every day. To produce the cruel products like meat, milk, egg, leather, and wool from animals that humans really don't need and have much more substitutive choices. The livestock industry waste great deals of food crops, fresh water, farmland, fossil fuel, and their emission cause health global warming, destroy forests, pollute rivers, and cause many diseases. They force the lives, like everyone here or our pets, to live in the hell and lie to everyone that you need their products so they can profit. What I want to say is, technology hardly saving the humankind because human can do without petroleum oil. Only respect to other creatures live on this planet will ease the crisis. So I think it's our duty to be animal-free vegetarians. Thank you.
好，谢谢你的观点啊。我们是不是后面的那边好不好？
我有一个问题，如果说 如果说海平面持续上升，然后台湾没有做任何处理，台湾还会有几年？
台湾有没有解啊？台湾其实，我的理解是，其实起伏蛮多的，不像有一些这个真的比较面临马上的问题的一些小的岛国，这一点那个杨教授应该是有比较更多的体认了。
面对这个海水面上升，应该是全世界的一个议题了哈。那针对台湾，当然在刚刚我有讲过，就是说对于整个这个，因为台湾毕竟它是一个地狭人稠的一个国家，那么从环保面，那还有从工程面怎么样去进行？那对于工程师来讲，我们所考虑的是，在海岸防护系统上面，我们怎么样去做到去保护台湾？那当然也不可能去建太高的这个海堤来保护，所以一切的考虑，我们可能由以往的从线的保护，去考虑到从面的保护，包括把海堤前面我们再去做一些比较柔性的一些，把一些海滩去增加它的一个海滩的宽度，来消减这个包括这个海平面上升以来这样的一些水流的能量跟波浪的能量。那这是从工程师的一个观点。那从环境议题来表，我想怎么样去降低这个 CO2 的排放量？那这个是每一个人都要一起来做的。这是谢谢。
大家好，Dr. Church， 还有两位博士好。在问问题之前，我先要讲一件事情。我今天是骑脚踏车来的。因为大家都一直说那个要节能减碳，还有刚才那位小姐，sorry， 我也听得很紧张，所以忘记你的名字。那个我本身是工程科学系在职的研究生，而我任职于新达发电厂空污改善这个部门，所以其实罪魁祸首应该是发电厂。那我这里有一些资料，可能 CO2 其实有规划6种化学物质是温室气体，那其中 CO2 是占比例最大。那我这些资料是台湾其实占全世界排放 CO2 是大概有1%，所以大家很厉害。那其实台湾电力公司主要发电量的话，70%是燃煤发电。那其实大家都一直说，要节能减碳，节能减碳，可是好像大家都很反核四。那其实核能发电是不会制造任何 CO2 的。那我想要问一下那个 Dr. Church 说，那个你们在澳洲，你们是支不支持那个核能发电？然后还有你们刚才说政府有哪些？例如一些方法、一些机制，例如说，抽能源税，因为你一定要有一些钱来成立一个部门，例如台湾电力公司，我现在部门只有环保署只有管制 SOS 跟 NAS， 还有一些 particle 的空污费，可是 CO2 却没有。那请问你们澳洲有没有一些可以让我们学习的地方？谢谢大家。
谢谢这个。这个电力公司power plant 这个直接的这个感受，我先插进来讲一两件事情。刚才他提到说，发电厂是罪魁祸首，其实不是啦，是我们全部都是罪魁祸首，真的。那刚才那位女同学问到说，那我们在台湾每一个人能做什么？其实我觉得一件事情，我们每一个人都会做，都能做，而且马上现在就可以开始做，回家就可以开始做，就是节能减碳的那个节能，太容易做了，你随手就可以做。譬如说我刚来出来，我电脑就关掉了啊，当然我不是，对不起，我不是骑脚踏车来的，真的就是每一点滴都是聚起来就是很大。你可能可以注意到说，我们要发展替代能源，想尽的办法弄一些这个太阳能、一些风能，那个量是微乎其微。不管你做了多少投资，甚至超过你的这个的回收， 那个量都是少到0点几的那种味道。但是我们随手可以做的，你随手我相信每一个人回去，你生活里面是节省个10%太容易了，20%太容易了。你真的做到，比花大功夫去做新的能源，去开发新的替代能源，那些东西都还有副作用，还有我们意想不到的这个可能制造的新的破坏，都容易做到。我们随手的节省节约是我们每个人都必须能够做，而且必须做。那我还是把刚才这个问题我继续问一下 Dr. George John. He wants to know what's the Australian policy on using nuclear power in generating national resource.
The Australian government's policy is against nuclear power. They're not in favour of it. The current push is on for renewable energies. There is a target for renewable energies which looks like it will be met, and I suspect at some stage that will be increased. Renewables in this case is wind, hydro, solar, and in the future geothermal will be one of those. There's also a large push on for carbon capture and storage for coal-fired power stations, but the Australian government is not in favour of nuclear power.
所以大家都听到了，目前来讲，澳洲政府还并不是全力赞成nuclear power， 当然有他们的考量以及他们的历史的这个原因。刚才其实同样还提到一点，就是台湾以我们这么少的人口，这样子的生活水平，这样的生产力，我们为世界制造的这个二氧化碳排放量，其实我们是很应该很惭愧的。我们是世界上有名的坏孩子，我们每个人都有责任。因为时间的关系，也许我们再1-2个问题，好不好？那后面那一排好了，好不好
？Hello, Dr. Church, Dr. Zhao, and Dr. Yan. My name is Ken. I want to ask Dr. Church about the global warming discussion in Copenhagen last year. How was the opinions and ideas from Taiwan, Japan, or the other countries in Asia? Thank you so much.
I don't think I can answer that question. I'm not part of the political process. My views on Copenhagen is that some progress was made in that that nations agreed that we did have to limit global warming to 2 degrees Celsius. There was agreement that every nation had to play a part, which was a significant step forward. But the meeting also fell short of what many of us had hoped would happen.
因为时间的关系，我想大家真是都欲罢不能。不过后面我们再开放最后一个问题，好不好？
谢谢赵教授的那个厚爱啊。针对刚才的问题，我想问3位啊。安平就是台南市，就是在三角洲的地带，盐水溪还有运河。那么我们现在都市计划里面一直在讲说要回复17世纪的安平的那个海域的问题啊。那不知道水工所这边呢有什么样子的看法？还有一个就是说我们还有一个就是说我们现在呢面对的就是说山的威胁。你说要搬到山上比较高的地方是受山的威胁，那么受海平面上升我们也是威胁。 那台南社大呢，长期都在监控安平海岸沿岸的那个沙滩的那个情况，那有发现真的就是有退缩的现象哈。那我们现在又要去扩大我们的海，让海直接来到我们的社区的边缘，那这个是不是会有所影响？那么另外一个问题，我要请问那个 Cheng-Shing 教授，刚刚在图片上面有一个，就说我们怎么因应这个海平面上升，那画了几张图片。那其中有一个我蛮有兴趣的，就是说有一个房子，它是倒三角锥形状的，那个是不是说仿照船一样呢？我们是不是以后的建筑要像一艘船的那个设计？我不知道这个是不是这样子的意思。谢谢。
我想第二个问题我们都不是专家哈，不过第一个问题我想杨老师应该比较有。
像针对台南市沿岸的地方的这个海岸线的一个侵蚀的问题，那目前就我知道的台南市政府跟6合级都有针对这些7位有所谓的海岸线的一些监测计划跟养滩的一个维护计划，那目前都是正在所谓的研究评估当中了哈。那目前的想法当然是希望能够去扩增原有这些海岸的沙滩的一个能够恢复以前的一些风貌，把这个侵蚀能够去做改善。那以成大水工所的立场来看，我们是很希望借由后续包括可能5年500亿或什么样的一个计划，我们希望在我们台南市的门口就能够建置一些像美国一样，它有一些海上的一些观测平台，能够长期去监测这个区位到底它的这个海浪跟这个疏沙的一个变迁的情形，因为唯有比较长期的这样或者是很密集的监测，你才能够去对这个区域提出一个好的整治方案。那这个是目前我想我们正在规划跟进行当中的。那这是我的回复，谢谢。
时间真的已经我们租场地已经超过了，所以我已经被警告了。我想大家真的对这个议题非常的关心啊，对今天的讨论，今天的大家吸收到的新知识，我想大家都应该很有收获。那我想今天我们到这里结束。不过刚才 Dr. Church 跟我讲说，他有一个小小的礼物想要送给我们2位。我们说我们只是在代劳，实际上真的应该感谢的是这个思沙龙以及龙应台基金会吧啊。还有一个小礼物想要送给龙应台基金会。
今晚的沙龙即将在此结束，感谢远道而来的 Dr. John Church 与赵峰院长，以及代表台南及成大的杨瑞元博士，一起为我们带来这场意义非凡又深度匪浅的沙龙。The salon is about to end. For giving us a meaningful and profound salon tonight. We give special thanks to Dr. John Church from Australia and Dr. Zhao Feng from Taoyuan and Dr. Yang Ruiyuan, who represent both of Tainan and National Cheng-Shing University. 让我们再次掌声感谢他们。Please give our special thanks to again. Thank you for your participation in the salon today. Good night.